So how many of you heard about SN1 reaction? Even how many of you know about how many type of reaction are there in organic chemistry? So I will tell that there are 4 type of reaction in organic chemistry. That is substitution, addition, elimination, and rearrangement. These are the main 4 type of reaction. Also, there are other type of reactions. So substitution reaction, as you can see that one group will be substituted by another group. That is substitution reaction. Addition reaction means one molecule will be added to the another molecule and the product will be formed. In elimination reaction, one or two small molecule will be removed from one of the substrate. And rearrangement, you can see that the product rearrange to form a new product. So these are the 4 type of reactions which are dominant in organic chemistry. So we will discuss today the SN1 reaction, that is substitution nucleophilic unimolecular. So this is one type of substitution reaction, and I have taken this presentation from the slides here, and this is shared by Mr. Dheeraj Kumar Nikam, Assistant Professor, Pharmaceutical Chemistry, Bharati Vidyapeeth College of Pharmacy, Navi Mumbai, India. So we'll discuss the following things. Features of SN1 reaction, SN1 mechanism, stereochemistry, carbocation stability, carbocation rearrangement, and factors affecting SN1 reaction. So this is substitution. In previous video, we had discussed about SN2 reaction. You can watch that video. So what is SN1? Substitution nucleophilic unimolecular. So this one is coming from the molecularity of the reaction, that is unimolecular. And I want to tell you that this follow the first order kinetics. So I'll come into these points. So SN1 reactions features are, it follow the first order kinetics and it gives the racemization product. You know about the racemization, it gives 50% of both R and S compound. This is a non-stereospecific reaction, and carbocation rearrangement sometimes takes place in SN1 reaction. The reactivity sequence of substrate is 3 degree, greater than 2 degree, greater than 1 degree, then methyl, greater than methyl. So here is the mechanism of SN1 reaction. First, the substrate. This is the two-step process. In the first step, the Cl, the leaving group, will depart and it will form a carbocation. And as you know, the carbocation must be stabilized by the factors like inductive effect, resonating effect, or hyperconjugating effect, because otherwise the carbocation will not be formed and the reaction will not take place. So in the first step, the carbocation will formed, and in the second step, the carbocation will undergo addition with the nucleophile and give the product. So carbocation has a planar geometry. So both the p orbital are perpendiculars to the plane. The nucleophile can attack from upper or from the lower direction of that plane. So as a consequence, product with 50% mixture of both the optically active isomer will be formed. So this is in this reaction, racemization will take place. So this is an example: tertiary butyl bromide the reacts with the OH group and to form the tertiary butyl alcohol. Now this is stereochemistry. As I told earlier, that this is a 3-degree carbocation will be formed, which has the planar geometry, and the vacant p orbital is perpendicular to that plane, and this p the nucleophile can attack from both the p orbital, that is from the back side as well as from the front side. So both the product can be formed, and it will form in a 50% ratio, so racemization will take place. And one thing I want to tell you, that first step is the slow step. The activation energy requirement for that step is high, and second step is the fast step. So for that, the activation energy requirement will be lower. So this is the energy diagram. So reaction progress of reaction, that is two activation energy, two-step process. So for the first step, the activation energy requirement is higher than the second step, and this is the intermediate carbocation. Now this two is the transition state 1 and 2. As you can see, the transition state is polar, so the solvent will affect the reaction rate. If the polar solvent will stabilize the transition state, so the activation energy requirement will decrease as well as the rate will increase. This is the structure. Next, again, as the carbocation is the intermediate, so electron donating group will stabilize the carbocation, so the rate will be so the formation of carbocation will be easier for electron donating group attached to the carbocation. And if electron withdrawing group is attached to the carbocation, then the formation of the carbocation will be difficult as well as rate will be slower. So how the carbocation can be stabilized? There are three factors: inductive effect, hyperconjugation effect, and resonance effect. So inductive effect, it is a polar effect. The methyl group provide the plus I effect. It is due to the electron negativity difference mainly. So the plus I effect of 3CH3 group will give stability to the carbocation. Now hyperconjugation effect, this is the slight overlap of the CH bond, that is sp3s bond, with the perpendicular p orbital. So this is a very weak effect actually, but 3-methyl group will have 9 hyperconjugating conjugative structure, so that will stabilize to some extent to the carbocation. Also, resonance can give the stability to the carbocation because the positive charge that pi p can delocalized into the benzene ring through resonance. Now the stability order, as you can see, the tertiary carbocation is higher than the benzyl cation. It is almost equal to the allyl cation, because benzyl, it is resonance stabilized as well as allyl resonance stabilized carbocation, then a secondary, then primary, then methyl. Vinyl is least stable because here the sp2 hybridized carbon is carrying the positive charge. So sp2 hybridized carbon, it will have a higher electronegativity, so that will be destabilize the carbocation. That is why vinyl cation is least stable carbocation. Now carbocation rearrangement can happen in the intermediate stage because, as you can see here, a 1-degree carbocation, if an hydride shift takes place, then the carbocation will form a 3 degree carbocation, so it is a far better stabilized carbocation than before. So it is very desirable that 1,2 hydrated shift will take place from this type of carbocation. Now alkyl shift can also happen. Here the methyl group is shifting, 1,2 shifting is happening, so 3 degree carbocation will be formed. Again, this other carbocation rearrangement reaction is a 4-member ring will expand to the 5-member ring. This is an aryl shift is happening through a 3-member intermediate carbocation, as you can see. Now factors affecting the SN1 reaction. Nature of the substrate, as we discussed earlier, that 3 degree carbocation will give a stable carbocation, 3 degree substrate will give a stable carbocation, so the rate will be much higher than this. So the relative rate of tertiary is 10 to the power 6, and secondary is 1, primary is 10 to the minus 4, and methyl is 10 to the minus 5. Nature of nucleophile. Nature of nucleophile will not affect the reaction rate because the first step is the slow step, and in the first step there is no involvement of nucleophile. So nature of nucleophile will not affect the rate of the reaction. Now factors affecting the SN1 reaction is the effect of leaving group. The higher the leaving group ability, lesser will be the activation energy, so higher will be the rate. Solvent effect, as I stated earlier, that as the transition state is polar, so polar solvent will stabilize the transition state and it will decrease the activation energy requirement, so it will enhance the rate of the reaction. This is the leaving group order. Like lesser the basicity, higher the leaving group ability. This is tosylate, a good leaving group. Then iodide also is a good leaving group. Then bromide H2O F minus. This is the order. So basicity order is inversely proportional to the leaving group order. This is the polar protic solvent. Order of polar protic solvent means higher the polarity, higher will be the rate of the reaction. So summary of the reaction, kinetics will be the first order, rearrangement, it will undergoes carbocation rearrangement, product 50% inversion and 50% retention, form racemic mixture. Nucleophile unimportant, any nucleophile can perform the reaction and the rate will not depend on the concentration of the nucleophile. Leaving group is important because higher the leaving group tendency, lesser will be the activation energy and higher will be the rate. Solvent, higher the polarity of the solvent, higher will be the rate. So thank you. These are the things which I wanted to discuss today. This is a reference. So have a good day. If you like this video, please subscribe my channel. Thank you.